So now I'm going to do another just kind of a simple video. No diagrams or anything. We have power supply set to 5 volts. The main focus of this video, we're going to actually cover a lot of stuff, but we have a Schottky diode right here. So we're going to talk about what a Schottky diode is. First, we're going to talk about a diode. We have a light emitting diode. So this is a diode here that is made to emit light. Up here is just a regular rectifier diode. And so we apply power, and you can see that we got light flowing. Probably 2 milliamps of current flowing, even though this shows 1 milliamp of current. It's not as accurate as a multimeter. But there you can see, lamp is at the brightest setting. Not terribly bright lamp, but it's the brightest setting. And you can see I dimmed it, I brightened it there. The blue LED is pretty bright, even at very low current. It's a diode though, light emitting diode. If I put it in backwards, so now the long lead, the anode, is to the positive supply, short lead, the cathode is towards the, short lead, the cathode is to the positive supply. Pretty sure I said that wrong. Long lead, the anode, is to the negative supply. That's backwards. Normally the anode is to the positive supply and the cathode is to the negative supply, and you get light through the LED right there. So if I say anode, I may instinctively say positive side, but that's only while it's forward bias. Now we're going to grab a rectifier diode right here. Again, it's a diode. Its job is to let current flow one way but not the other. You know, that's what the LED did, but usually you don't use an LED in that way. You may find circumstances where you do, but generally you don't. So yeah, there we got the diode in series with the resistor, the LED. If I put the diode in backwards, our rectifier diode right here, 1N4001, and there's a gray band where the cathode is. It's hard to see even in person. It's really dark, but any case. Right now the cathode's to the positive supply, the gray band, the anode, side without a band, to the negative supply. It's blocking current. I turn it around and it will conduct current. Then we have the Schottky diode right here. So a lot of this isn't going to make sense until we get the multimeter. But again, I'm going to put the Schottky diode forward bias, and before I forget, the Schottky diode is a 1N6263. I know that because I grabbed it out of this bag. It's from the Joe Knows Electronics semiconductor kit. They sell a number of different kits. I recommend the semiconductor kit once you have basic components. So it doesn't include the basic components. It has a bunch of different types of diodes and transistors for the most part. So in any case, there we go. Forward bias, the LED lights up. Again, reverse bias. So that's a rectifier diode. And I said it lets current flow through one direction, blocks current the other direction. Schottky diode does the same thing. So technically, it's also a rectifier diode. The difference is that it drops less voltage. The LED drops about 3 volts. We'll see that when we grab the multimeter. It's dropping it from the resistor. The power supply has 5 volts. It keeps providing 5 volts. Resistor sets the current based on the voltage across it. So power supply's got 5 volts. Blue LED drops about 3 volts. It's not perfect. It changes a little bit based on how much current is flowing through. Probably going to be a little bit lower now, but maybe it will be spot on 3 volts. But in any case, drops about 3 volts. You got about 2 volts across the resistor. That's the main thing to keep in mind. If you have other diodes in series with it, they also drop some voltage. Now obviously, they're not dropping 3 volts because that's 3 volts. That would drop 6 volts. It would take 6 volts before any current flows. When we put them in series, it wouldn't lit up at all. So the regular rectifier diode, 1N4001, that's the one that comes in the vast majority of kits. It drops about 0.7 volts approximately. Again, changes a little bit with current. At these lower currents, it'll probably be closer to 0.6. I haven't measured anything yet. I'm just going by memory right now, but that's common knowledge, about 0.7 volts. Schottky diode, it's going to be closer to 0.3 volts. Again, it varies with current. It may be down to like 2.5. I'm guessing. I could be wrong too. I'm just going by memory. But technically, usually it's about 0.3 volts forward voltage. So when we put them in series and we have, some circuits you may notice a big drop in current if the diode is dropping too much voltage. But in this case, we probably won't see a light difference, but we'll see a voltage difference with the multimeter. So now, I got the multimeter here. Again, power supply is still 5 volts. Maximum of 20 milliamps of current in case I short circuit or something. So just a way to help protect from something bad happening if I do something wrong. Now, we don't have to move the red probe for anything other than high current with this meter. It's auto ranging. I just have to set it to V. If you ever have numbers for any of the settings, set it to a number higher than you expect to measure, and especially current. But it's always best to just set it to a higher number. Now we got the probes right here. And what I am going to do, instead of holding the probes against stuff, for one thing, that can mess up the measurement, especially with this cheap board. If I press on anything, it will likely make a worse connection. Best case scenario, it makes an even better connection. It's a cheap board. But in any case, probably a worse one. So yeah, we got these jumpers that I made attached to it. So first, we can look at the supply voltage, and this is really going to be the voltage across the resistor and LED. So again, it's a cheap board. Connections are not as great. There's a little resistance wherever there's connections, and that's one reason why we got a lower voltage than what you see on the supply. Also, the supply may not be perfectly accurate, but in any case, there we go. It looks like about 4.99 volts approximately. So that is what is across the resistor and LED. As I said before, the LED, the blue ones, drop about 2 volts, which means out of the 5 volts that you see right there, that's across the resistor and the LED. I'm just going to go up to both sides of the LED there. We got about 3 volts. Again, this is lower current, and therefore it's down a little bit. One thing I can do is zoom back, and with more supply voltage, we need to stay below 20 milliamps of current. You're going to see the voltage across the LED goes up a bit. It's based on how much current is flowing through it. The rest of the voltage is across the resistor. So we got 3 volts across the LED right now, 10 volts total. That tells you there's 7 volts across the resistor. So we'll do that first. We'll go across the resistor. So that's voltage drop. All diodes have either a little drop or a lot of drop. You need to make special circuitry if you want it to conduct without a drop in one direction and stopping current in the other direction. But there you can see 7 volts. But the main thing was we were working with 5 volts. At 5 volts, there's 2 volts across the resistor. So that's what's setting the current. So it's very important. Maybe we'll do 4 volts later. You can see we only got about 1.2 volts to work with. And so we really can't lose much of that voltage at all, or it will affect the circuitry. Let's go back to 5 volts. So in any case, we got about 2 volts across the resistor. 3 volts was being dropped by the LED. So now we got a rectifier down. So a gray band, it may show up on camera, but gray band is the cathode. I can't see it in person, but it's not super easy to see. So I can tell, quickly, but it doesn't stand out very much. Camera is washing it out even more. But in any case, trying to be careful here. I don't miswire anything, although there will be no damage. So the blue LED, it looks just about as bright. But here you can see we still got that 2.2 volts basically because of how we're measuring it. We're measuring both the diode and the resistor. So we come here again, the voltage across the blue LED, it's a little bit lower now because current has gone down. So I wasn't even thinking about this, but that's something I should have expected right there. And so about 3 volts across there. And now we'll just measure across the rectifier diode. 1N4001 again. This is the diode you typically get in kits right there. Same part number. May look a little different. Leads may be longer and shorter. They may color it kind of differently. But the electrical properties that it has is the one that you get in kits. And I think something's just kind of loose. But yeah, we got about 0.6 volts, which I expect at this current. I said that before. About 0.6 volts. So we go there. That 0.6 volts, we already dropped, about 3 volts from the resistor. Now this is dropping about 0.6 more. That's the main takeaway. So we had about 2 volts across the 1000 ohm resistor here, which gives you 2 milliamps of current before. Now we got about 1.6. Remember, this is a little bit less than the 3 volts that we expected. It's closer to 2.7, I believe it was. So, in any case, we don't have -3, 2 left over there. We're dropping about 0.6 more right there. And therefore, we got, a fair amount less than 2 volts across that resistor. Not a big deal in this circuit, but something you got to be aware of. Now, when I put the Schottky diode in, you're going to see, and a black band is right here. I'm going to put it the same spot I had the gray band for the rectifier diode. And we plug it in there. There you can see. So, before it was 1.6, I believe, with the just a regular silicon diode right there. This is a Schottky diode, specially made diode to conduct a little bit better. At a slightly lower forward voltage. So it's conducting. So there you can see. We got some more voltage across the resistor, which is the main thing. That's what's setting the current, if that's a problem. Again, there's complete circuitry you can make if you need it, where it drops practically no voltage at all with forward bias. But if you can afford to lose this much forward voltage, you can just use a Schottky diode. There we go. It's reverse bias. It's just blocking all voltage. Although there is some trickling that goes on, so you may, see that a little bit of voltage might register on the meter, but that's only because there's a little bit of trickling going on. But that did show 0. There you can see we got the 5 volts. All of that 5 volts. Again, this may give us a kind of a weird number because there's trickling going on, but that's dropping voltage. That's dropping voltage, but if we set the meter there, you can see we got all the voltage across the diode there. It's blocking. It's doing the best job blocking current in the circuit, so it's going to have the most voltage till we put it forward bias. And again, you use these for rectification when you need them to drop less voltage. They tend not to handle as much current. Of course, you can buy bigger ones that can handle more current. So like really high current circuits, you may see the regular rectifier diode. There again, it's forward bias, about 0.6 volts across it. Same thing if we reverse bias it, right there. So, it's got, basically all the voltage across it. Although you got voltage drop with the diode as well. If we put the resistor to the negative supply right there, there you can see it's pretty much the full voltage. That's negative side of the multimeter, ground right there. That's our 0 volt reference point. This is about 5 volts higher. That's how it's showing that on the display. If you put it backwards, you get a negative voltage. But yeah, if I put it to the negative rail, it's probably exactly the same right there. Might be a spec different or something. And I don't think it's making great connections. It's a cheap board. But yeah, that was the main takeaway for this video. Again, as I said, make sure you turn meter off when you're done. It's just going to beep to let me know it's still on, and then at some point it will shut itself off. But you never know. Maybe you have a meter where the battery will die. But yeah, the Diodes Electronics Semiconductor Kit. It's just a box filled with a bunch of these baggies. No point showing them. Each baggie, though, has the part number. You can take the part number, and on the box, it tells what those part numbers are. So just be aware of that. But in any case, just buy like components like that and do simple tests like this. You'll get familiar with the component. Obviously read up about the components, about rectifier diodes, Schottky diodes, and, everything else. But also, collect some of the basic components that, don't come in the basic kit. A little bit more complex components, but they're still basic components. You'll see Schottky diodes in lots of circuits, and you'll see a lot of the components that I have in that Diodes Electronic Semiconductor Kits in circuits. You'll find uses for them if you make a lot of circuits, so still good to practice them. But, they're not the basic components that are in practically every circuit, but it's still a good idea, just to do this little testing right there to get familiar with them. To really understand them, great, you need to read the material, but to get a basic understanding of them, you kind of have to use them, So, in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. That'll help a lot. I'll see you in the next video.